Okay, this problem, standard normal, by definition. Okay, this problem, it's asking you to find the probability between two z-scores. We'll use the standard normal distribution. So use your normal calculator. Will mean it's 0, sigma is 1, and you're looking for the probability between -0.79 and 0. Why it means 0, standard deviation is 1? Because it's the z-score. When we talk about if you want to find the probability between two z-scores, and that means that related to a z-score, that means the normal distribution is the standard normal distribution. So you can use your normal calculator. Okay, this is the answer. If you get from normal calculator, use the between tab. Okay, this one we'll also use a normal calculator because here it says the normal distribution. So normal calculator. And the mean it's 9, standard deviation it's 2. You want to find longer than 12 inches, so you're looking for probability to x greater than 12, and then use your normal calculator to find the answer. Okay, so that's 0.0668, or it's 6.68% if you move the decimal place to right by 2 places. And then B, how many would you expect to be shorter than 6 inches? Let's find the probability of x less than 6 first. Okay, use normal calculator, same thing. Okay, so x less than or equal to 6, it really doesn't matter if you put equal sign or equal sign, you the same thing. It's also 0.0668, and then there are 300 fish total, so we'll have to use 300 times 0.0668. That'll give you how many fish it's shorter than 6 inches. So use the calculator. It's probably 20 fish. Okay, so this problem, if you graph that, we'll also use the normal calculator because you're given a probability. This is like probability percentage. You want to find the z-scores. So the mean, it's 0, standard deviation, it's 1 for the standard normal distribution. You will have z-score. Then if you graph that, it's 75% between, or 0.75. 75% it's 0.75. And you're looking for this two z-scores. So just use your normal calculator, put 0 for mean, 1 for standard deviation, and then put 0.75. So you'll use the between tab like this, and put 0.75 here, and then you can find the answer. So if you use your calculator, you can find the normal calculator, you'll find the answers are two z-scores, -1.15 and +1.15. That's how you put your answer. Okay, this problem, it's still related to the normal distribution, and we'll use the normal calculator still. So here mean it's 65.4 inches, and the standard deviation is 2.7 inches. What height represents 80th percentile? Which means you were looking for the percentile is always less than or equal to. So you will put 0.8 as the percentage, as the probability, and use compute to figure out the answer. For leave this blank. So the answer is 67.67. That's the height to represent 80th percentile. And the first quartile, it's 25%. So same thing. You will use normal calculator to figure out the height. So leave this blank, and then put 0.25 represent the first quartile, and they can get the answer. So that'd be 65.8 point, sorry, 63.58. Yeah. So that's how you would do this problem. And this problem, as the sample size increases, the standard deviation of the distribution of sample means increases. It's not correct, because according to the central limit theorem, the mean of x bar is the same as the mean of population mean, and the standard deviation of x bar, or standard error, is equal to the sigma over square of the sample size. So this is standard error, or you can say standard deviation of sample means. So the right answer should be, that's false. It decreases. As the sample size increases, then the standard deviation of sample mean decreases. So it's as the sample size going up, the whole thing is going down. Okay, this is also a central limit theorem problem, because as you this problem is like one woman with a height less than 65.8. That's just the normal calculator. So because it's a normal distributed problem, so mean it's 63.8, and the standard deviation it's 2.7, and you're looking for probability that x is less than or equal to 65.8. So you just compute to figure out the answer. So the answer is 0.7706. And okay, the second part is the sample of 20 women with the mean. So this time we'll have to use the central limit theorem. If you want to find the mean of a group, then use central limit theorem, which means we had to figure out, okay, what's my standard error? That's equal to sigma over square root of n. So use your calculator. That should be 2.7 divided by square root of the sample size is 20 women. This is my sample size. So figure out that first. So 2.7. Okay, it's 0.6037. And then in the normal calculator, we need to change the standard deviation to, we just figure out to, okay, hold on. Okay, we just need to figure out, change this to 0.6037 and use the same way, still the same mean, still need to figure out what's the probability that x is less than or equal to 65.8. So only change the probability, only change the standard deviation, and then the answer will be, sorry, okay, the answer should be 0.9995. Okay, by changing the standard deviation to 0.6037, that's changed. Your answer is changed too. Okay, so the chance definitely is higher for select a mean of group 20 women with a height less than 65.8 inches. Sorry, because it has a higher probability. So that's the answer for that. Okay, for this problem, just use the normal calculator. You need for the mean, it's 0, because this is a z-score, as you can see. Oh, sorry, it's not z. The problem tells you that it does not say z-score, but means 0. Standard deviation is 1, and then you're looking for a probability of x is greater than or equal to 81.30. So 0.9032, and that's the answer for, so the answer should be D. And this is central limit theorem. So the mean, the mean it's the same as the population mean, 159, and the standard deviation or standard error of the standard error, which is the standard deviation of sample means, it's equal to the sigma divided by square root of n. So 24 over square root of size 9. So 24 over 3, which is 8. So the answer should be D. Okay. Which level widest? Then sure, it's the highest level confidence has the largest error, margin of error, which means the widest confidence interval. Oh, sorry, I didn't see the second part. 99%, both are 99%. So it's the since by the formula, if you remember the formula, z score depends on the level of confidence. If the level of confidence is bigger, then the z score it's bigger. That's why B is correct. I didn't see the read actually the second part of the problem when I checked the answer. In this one, it's the relation between the level of confidence and the width, which is the error. The width is twice of the margin of error. So if the increase the level of confidence, then it will widen the confidence interval, make the level be make the error be bigger, and then the sample size will narrow. So if you have more sample, then you will get a less error. And then the standard deviation is bigger, then you will get again widen, because your number, if you have a larger standard deviation, then that will make you have bigger error.